So, this question, given that p is a real number, prove that this equation has real roots. Okay, so there's something we need to know. If we look at the minus p formula for a second, this finds the roots of quadratic equations, what this is. Okay, but there's something about it. If you look at this part of the quadratic equation, this determines an awful lot. For example, if b squared minus 4ac, so if this was a negative number, it was less than 0, could we get the square root of a negative number? We couldn't, so therefore the roots are imaginary. Okay, not the scenario we want. Another scenario that b squared minus 4ac could be if it was equal to 0. So if b squared minus 4ac was equal to 0, we could say the roots are equal. The fact that the roots are equal indicates that they're also real. Okay. The other scenario is if b squared minus 4ac was greater than 0, the roots are unequal. They are also real. Okay, they exist. So these are the two scenarios where roots exist. These are when the scenario when it doesn't exist, the roots are imaginary. So this is the scenario that I want. I want to be able to combine these two together. Okay, so this is what I want. I want b squared minus 4ac greater than or equal to 0. So I have to find a, b, and c in this. First of all, I'm going to have to factorize the x out there because it's not in the form that I want. I want x squared first, which it is. I want x next, but there's two x's. So I'm going to take out x. And if I take x out of that, I'll be left with minus 4p. Take x out of that, I'll be left with minus 1. So now I can see that a, b, and c. A is the number in front of the x squared. B is the number in front of the x. And c is the number at the end. So I'm going to put all them three into this equation. Okay, so it's b squared minus 4ac, and I'm hoping that's greater than or equal to 0 because I want the roots to be real. So I'm going to square this out. I'm going to do it the quick way. If you want to do the quick way, you'll have to multiply it out, 2 brackets and all that. Okay, so here's the quick way. Square the first, multiply the first by the second, and then multiply your answer by 2, so that would be plus 4p plus 8p, and square the last. Minus 8p. So they will cancel. So you're left with 16p squared plus 1. Which is true. Why is this true? Because p squared is positive. You multiply by 16, which is still positive, and you add in 1 to it. So therefore this is going to be positive. So therefore roots are real for all values.